of programming? The aim of programming is to model the reality. Okay, we are people, or you will be, because most of you are not yet programmers. I hope you will be people that will have some skills that allows you to describe the reality in a formal way and force computers to work. Okay, so what is the problem? We have very simple stuff. I mean, computers, they work an idea that was really described in 30s of the previous century, Alan Turing, okay, the mathematician, and still they work in the same way, okay? So it's a really very simple idea, doing repeatedly the same simple things, okay? This is one end, and on the other end, we have human beings that want to do some things using these simple machines, okay? And our minds, as human beings, are not working in so simple way. We don't know what to do, we don't know what we are thinking, we don't know what to like, but we are at least the best on our earth, okay? So the problem is to understand the problem, to model it, to divide the problem into smaller things, and at the end, to code it in a very simple language, which is readable for us as a strange people, as programmers, and understandable by compilers and transformed into binary form. So why object-oriented approach is so popular nowadays? Because we have behind the programming, which is the last step of everything, okay? We have object-oriented approaches to project, okay? And this is important that when somebody starts to think about the problem and define some ideas, they are defining objects, relation between objects, methods, and finally, after several steps, we as coders are programming, okay? So object-oriented is really a way of modeling the reality, okay? And you should think about everything. Okay, object-oriented is not the only approach we are using, functional programming, but we can mix things together. And really, it was proved by examples, okay, maybe not theoretically, that at least up till now, this is the best way how especially large software projects could be realized, okay? And this is something that we are using during the last 30, 35 years, so quite long time, okay? So we have three main features of object-oriented aspects. And very often you are not following it. The first one is called encapsulation. This is a very important feature, and really, this is like a rule of thumb. Everything should be hidden. Only exception should be shown outside, okay? So that's why in many languages, like, for example, Java, we have modifiers like private, okay? So by definition, everything should be private. Only things that has to be really exposed will become public, okay? So this is a very important aspect. So, and it was really the idea of James Gosling discovering or designing Java, okay? Because all public elements are really dangerous. Even more, it is really a rule of thumb that all attributes should be hidden, okay? The main idea is that almost everything, I mean, the implementation should be hidden, and only some interface, only things that are called by others should be made public. So if in your code you have a method that is public and it's not called by outside class, it means it's an error, okay? Because it's not there's no need to be public, okay? A really simple rule, but it is really proof. It could be proved by example, especially large projects, that everything what is public is dangerous, okay? Why it's dangerous? Because others are using it. It means that it should not be changed, okay? Because in our everyday programming, we are very often programming in large groups. So really the hardest point between people is to establish some borders between them, some rules, okay? And even it's the same in the case of programming. We have to establish borders between different classes, between different programmers, okay? So So, and they have to be fixed because changes in interfaces are really hard then to be analyzed. Okay, so we are just only defining the external interface, and if anything else will be private, encapsulated, hidden, it means that there's a big chance that if you will change, because never think about it that programming is to making a code and forgetting about it. If your code will be a success, it means it has to be changed in the future. Because if you are doing something for some company, for some users, and if they are happy with your code, they want to add some extra features. Okay, so you have to change and modify the code all the time. So we have a continuous integration, continuous changes in a code. Okay, for example, a large company like Nokia, that is responsible for developing software for BTSs, has changes in their software each 2 weeks. Okay, and major changes, let's say each 2 months, but small changes are released each 2 weeks, and they have thousands of products. Okay, so this is a really big problem, but this is reality. We are changing all the time, changing. So we have to be prepared for it. Okay, so that's why I have forced you, and I will force you during the lab to encapsulate everything and to hide everything what is possible. Okay, the second idea of object-oriented programming is the inheritance. Okay, so the idea that we can define a new class based on the parent class, and you don't have to copy all the code. Since we are still changing the code, since we are still extending the code, this is a very clever idea. Okay, so if I am adding a new feature, I'm just saying, okay, this is a new class that is based on the previous class, and that's all. And all the features are automatically copied. Okay, well, they're not copied really technically; they are just assigned to it. Compared with C++, we don't have a multiplying inheritance, which is a terrible thing in C++. And sometimes I'm joking that if I have problems with students, I don't like them. Okay, I'm usually asking the questions about the multiple inheritance, which is hard, and very few people understand it. However, of course, multiple inheritance is needed. That's why in modern languages we have something which is called interfaces. Okay, so abstract classes, abstract things. And the most sophisticated element that is called polymorphism. Okay, this is a very nice general idea on one hand. On the other hand, looking in a very deep implementation, this is just a pointer to a function, by the way. Okay, of course, this is hidden in an abstract way. Okay, so what is the object-oriented program? Right? It is the program that is based on idea of objects. Okay, and it's just like we're calling one object a method of the other object. So we can see the code as a set of objects and communication, but not just to see the code, to see the word. Okay, the aim of programming is to model the reality, whatever reality is. Okay, it could be an abstract reality, it could be some maths algorithm, but everything is an object. Okay, so the main idea, my main very general idea behind object-oriented approaches is that that we are modeling the reality by objects and communication between objects. Okay, so objects. What are objects in that very abstract sense? Okay, since everything is an object, so objects have state or could have a state. Okay, this is a very important aspect. Okay, state is problem. That's why we have functional programming and more advanced ideas. But let's forget about it. We are talking about very simple and basic things about programming, the most basic things, okay, ever could exist. Okay, so object is something that has a state, okay, has a behavior. Okay, so I could be also modeled as an object. I have a state. I have a color of my eyes. Okay, this is kind of the state. Okay, I have a behavior. Okay, I could talk. Okay, I'm talking. Okay, and a lot of people with similar features. Okay, that's why we need to have an identity. Okay, so I am a human being. You are human beings. We have similar states, similar possible states, okay, possible behaviors. Okay, maybe they are slightly different because of our states, but we have also identity. Okay, so object could be identified. It exists as a state of electrons in a computer. Okay, an object may have internal data, which gives it state. Okay, so the state is defined by that internal data. Okay, then object have or may have, okay, because you could have objects without it, methods, and they produce behavior. Okay, and we can distinguish one object from the other. Okay, so it has some border. Okay, it has a unique address in memory. Okay, so objects exist as a code or exist as a state in memory, but they model some real objects, some reality. Okay, and objects are instances of classes. And strictly speaking, in object-oriented programming, this is the only way to define a new type. I mean, to define a class. Right? In pure object-oriented languages, as Java is, C++ is not a pure object language. It's a C with classes, as it was first called by B.S. in early 80s. Okay, many years ago. So classes are synonymous with type. Okay, so okay, we have here a code, but you should think about the class as some abstract idea. Okay, so let's say I'm modeling the reality. I want to model a bulb. Okay, a light bulb. Let's say it doesn't matter how it is implemented. It could be like the old one with Wolfram piece inside, or could be a LED one. It does not matter. Okay, now. Okay, so it has a name. It's the name of the type. Okay, so that's why names are important and should mean something for human beings. Okay, so never ever called classes like 1, 2, 3, or maybe if they are responsible for numbers, yes, but just the name should mean something. And what you could do with a bulb, okay, you can turn it on, turn it off. Some bulbs has a possibility of brightening, some and very often then of dimming. Okay, so this is the interface, the functionality that could be done on a light, on a bulb light. Okay, so how we are doing it in Java? So Java is just one way of possible ways of stating that information in a formal way. It's a nice way because we have something which is called a Java virtual machine, so we can run it on almost any computer. But think about programming as really not thing to be run. Okay, it is one of the features, but programming is a kind of a book or text. It's for communication with other programmers, with you as a person in the future, and also with a Java compiler. But so it has to be just as simple as possible, as readable as possible. Okay, it should be not very sophisticated and unreadable. Okay, readability is very important aspect. Okay, so I will really point you out. Okay, you can formally, we have a language called UML. I will be not talking about it because this is not aim of our lecture, but there is a formal language, and the most popular nowadays is UML, which is diagrams that allows to graphically represent classes, and then you as a human being could very easily map it on a given language like Java or like any other object-oriented language. Okay, so we have a type, I mean light, definition of the type, and then we can create an object. Object is implementation, so it exists. It has an address. Here, the reference, okay, so it has to exist somewhere. And then on that existing element, you could call methods, on, off, etc. Okay, so other examples is everything is a class. Everything is an object, okay? So me as a person education system, or you as a person education system, has a name, maybe phone number, and some methods. Just notice here we have minuses. It means that an element should be hidden. And the rule of thumb. all attributes are hidden. All attributes are private. That's all. No discussion. I mean, it's very rare there could be an exception, but you have to define why the exception exists. So if I want to access a name, I have to define methods like setters and getters, set name, get name. Okay. So always, even for simple things, access attributes by methods. Okay. It is a very good idea and you have to follow it. At first, you have to believe me, maybe later on or during class, we could discuss why it is so important. But believe me, this is something that you shouldn't ever do in different way, okay? And how to state it and how to use it in a language like Java is just simply, I'm producing a person and I'm using that interface, okay? Why it is important to have interface? Because then if I will decide to change the implementation somehow, just to store name, not in string, but maybe in string builder for some reason, okay? I don't know why, but let's assume I will do some changes. If I will preserve the interface, nobody will notice it in the sense that still the class could be used. And reusability is the main idea of programming, okay? Your code, your classes, you have to think what is a possible future case of using your class. And you have to anticipate the future. What is a hard everywhere, even in programming. But why to anticipate the future? Because I will repeat myself again. If your code will be a success, it has to be used again and again. It has to be modified, changed, and reused. So if it will be written in a way that it is hard to extend it, it will be a failure, okay? So the end of the success. Okay, so encapsulation is the idea which is the basic idea of programming, but really it exists in our everyday life, okay? Just look in a modern cell phones, okay? Very often it is hard to open them. Even it is really hard to change the battery. Everything is encapsulated. We have an interface, okay? We have a screen, okay? We have touching screen, okay? But that's all. All the implementation is hidden. Because you could have different components inside, but still the same interface, okay? Based on Android. So encapsulation could be found almost everywhere in our nowadays life. Okay, if you have a car that is a diesel car, or if you have a car that is gasoline car, you drive in the same way. You are using the same interface. Really, okay, maybe on a gas station you have to take care what you are putting in your car, but when you are using, they behave very similar way. This is the idea of encapsulation. We are hidden. The implementation is hidden. Okay, and we are just only defining the public interface. So how to control the car? Okay, even if you have an electric car, it is controlled in almost the same way because people are used to it. So everything is hidden. Okay, and this is a very good idea from the technical point of view because it allows a replacement of things. And this is the way how we as programmers are modeling the world. So encapsulating things, the implementation have to be hidden, okay? This is the most important idea. Why encapsulation? Because it's nice, it's working. It really simplifies everything, okay? It simplifies even for the producer of the code. Very often, and everything is allowed to be done, there could be a lot of problems, okay? So hiding the implementation reduces bugs, okay? And it is more beautiful, at least for me, okay? So if I have a attribute, a property of some class, called, for example, name, as you can notice here, it is encapsulated, so it's private. It's private, that's why it is so important. Okay, well, of course, somebody outside, I mean, For example, I am developing the class person and you have to use it for some reasons. So only public part is important for you. And let's look, okay, I have a constructor with argument and I have a getter. That's all. That's enough. Okay. Why it's so important? Because when something bad happens in your code is not working, it means that probably, okay, you did a mistake somewhere inside, but it is easy to notice how it is used because it is used only in a public part from the outside. Okay. So if the name will be public, here somebody could change it to anything. If I have methods like presented here, I could add some extra validation, for example, to not allow to set the string equal to null, for example. So if here, and that's all. When I will make a name as public, it is unsafe. Okay, everybody could do whatever with that. So this is a stupid idea. So believe me, that is more beautiful if you still are not thinking that way. And believe me, that it is really more simple, by the way. Okay. Okay. So the first rule, all attributes should be hidden. The second rule, encapsulation of problems space in a class objects. So if we are doing something, it means that probably somebody, even maybe we as human beings, will use it. So the first step is to define an interface. So a set of methods. So the names, arguments, return values that will be used by others. And we are hiding the implementation. It's a kind of a black box, okay? Okay, the client may see the implementation, but cannot use it directly. And it is much better for producer, us as producer, because we have some space for future improvement. Very often we have to develop the code as soon as possible. So defining interfaces, the most simple implementation, and then when we notice that something is too slow, it's too much memory, then we are changing the implementation. But if we will keep the interface, which is the minimalistic set of methods from your class, it is possible. If we will make everything public, there is a chance that somebody already used something, okay? So then you are very limited to changes. And I will repeat again and again. Software is changing during the time. It's changing during the time. So code is changing, always changing, okay? It's not changing, it's a piece of rubbish. It means this is just for the lab for students, okay? Or we are not a good programmer if your code is not changing. So that's why we have modifiers, which I hope you are familiar with. Okay, so we have the idea of private and public areas. Okay, so public area, this is a class interface, so public methods, and very rare and a very bad idea, but sometimes it is used, especially for constants, public variables, but try not to use it. In Java, we have also the idea of package and protected access control. Okay? Package is like public, but within the same package. And about packages, I was talking a few words during the previous lecture. And protected is connected with inheritance and polymorphism, and they exist in other languages too, like for example, C++. Okay, so let's do something very simple, something. Okay? The most basic idea as for freshers, first-year students. I know we are mostly not freshers, so maybe it is partly boring, but I've added the slides 2 years ago after my experience with your oldest colleagues during the lab. Okay, because really what I have to do, I have to change your way of thinking. Okay, so what is a rectangle? Of course, it's an object, because everything is an object. Okay, whatever you are doing is an object. Just think in that way. Okay, so what are properties? of the rectangle. Okay, it has a length and a width. Okay, so you could do something with the rectangle. You can specify the length, the width, and for example, you need to calculate its area and perimeter. Okay, so at first, whenever you are defining an object, whatever you are doing, everything is an object, you have to just start from thinking, not coding. Okay, so define the name, define properties, and define the interface. Okay, so this is more or less how that idea could be stated in Java. Okay, so we have a class called rectangle, which is public. We have two properties with and length. It is integer, however, I don't think it's the best idea to make it integer, but because why not to have a rectangle with the length 2.5? Okay, so maybe it should be double, much better idea. But this is private. Okay, properties, attributes should be private. Okay, and I have defined here methods that does the things I have defined here. Think, maybe write it down, draw it using UML or some similar things, and then write it. Java, which is a very simple language, by the way, and very readable. Okay. So the name, attributes, setters, so methods that allows you to set it, and some getters, method that allows you to get some more sophisticated properties which are based on these basic properties. Okay, so we have a private area, hidden implementation, and a public area, the interface. And how to use it? I'm creating an object. Okay, so new name of the constructor, calling methods, and then printing on the screen. Simple, very simple. But do not forget about the idea. Implementation should be hidden. Implementation should be hidden, okay? If you are not following these rules, write it down using your pencil or whatever on a piece of paper. And when you will wake up, just look at it, okay? Try to memorize, okay? So we are creating an object and doing stuff. Okay, this is a rule of thumb. Okay, maybe it looks strange for the first point of view, but in real, more sophisticated codes, I'm trying to answer the question, it becomes really important. Okay, so if we have the idea behind it, let's go through very quickly with the specific aspect of Java. Okay, so how the language looks like. Okay, so defining a class, which you already did for the lab, we already did during the previous lab and during lecture. Okay, so we have a magic word class. We have to have a unique name within a package class called class name, and if the modifier used here is public, okay, it means that the class has the same name as the file. Okay, then we can we have the next magic word, I mean extends. Okay, so the name of superclasses. This is connected with the idea of inheritance. Since Java allows to extend only one class. Okay, so we don't have a multiple inheritance, but we could implement many interfaces. Interfaces, strictly speaking, are specially classes with all abstract methods. I will come back to it. Then we have a body, which defines methods, etc., and we have annotations that allow us to add some extra information. Okay, so then we can define fields. Field is defined as it was shown before. Okay, so we have a modifier, the type, and the name. Public modifier, then the field accessible from all classes. It should be forbidden. Okay, sometimes not, but by default. Okay, private modifier, but also other modifiers are protected. It is connected with inheritance, and we come back to it. Static and final I will try to explain it soon. Okay. Final, it's connected is also with inheritance. So bicycle has, for example, a cadence, a gear, a speed. Everything is private. Okay. Then we have methods. Okay, methods have a modifier, very similar to the others. Okay, so public, private, protected, name, which is unique, or not totally unique, because we have a static polymorphism, which I will come back soon. Okay, we have a list of arguments and a body, and return type is defined here. Okay, so methods have to have a unique signature. What does it mean, unique signature? Is the name and the sequence of types. Okay, so it is possible in most of the object-oriented languages to have two methods with the same name, but they have to have different arguments. Okay, so it is forbidden to have a second method in the same class called calculate answer and double int, but double it is okay. Double as one argument is also okay. We have exceptions, but I will come to it later. And we have a body, which is like in C language, C++ languages, enclosed between braces, okay? And usually the code finishes with the return something, if, of course, the method is returning anything. Okay, a lot of methods are public, but some of them that are just supporting methods are private. Overloading. Okay, so one of the idea of object programming, on contrary to the previous ideas, is the idea of overloading. So you could have a set of methods or list of methods with the same name but with different arguments. So I will come back. They have to have a unique signature. So the name and the sequence of types. Okay, and it is okay because all of these have different types. So when I will call an object of data artist and I will call the method draw, depending on the type of an argument, a given method will be called. But it is simple for the computer and it is done really during compilation. Okay, so because based on the type of argument, we could define which method is called. The next important argument with idea you should be familiar with are constructors. Constructors are a special type of methods, okay, that has exactly the same name as a type. Okay, so this is the exception in methods, in the method custom, that they are written in a capital letter, because in Java this is a custom. This is not an element of the language. Okay, that the name of classes therefore also constructors are starting from capital letter. What is the aim of constructors? Constructors are used to decorate the object. So set up initial values of its arguments. Okay, so very often you have a large set of constructors. Very often they are overloaded. Okay, with different set of arguments, and more or less very often looks like that. Okay, so you are just setting its initial value based on the argument passed here. We have something which is called a default constructor. So default constructor is a constructor without any arguments. Okay, if there are no constructors, there is a default constructor coming from the superclass. Okay, we'll come back to it later. The next idea that you should be familiar with from it is similar elements in other languages. Here it is this as a reference to the object itself. Okay, so we have a special element of the language called this, and it could be used only inside objects. Okay, and only inside not static elements of objects. Okay, why not static? Just wait a second. And it is used for two purposes. Okay, one of the purposes is shown here. So just notice we have x as a formal argument of the constructor and x as a name of the attribute. So how to inform the computer, the compiler, which x I have in mind? The idea is always very simple. If you are defining something closer to your code with the same name, it is making something that was about hidden. Okay, so if I will write here x equals x without this, it will mean that I'm just changing that x, which is a local variable, the value of the argument passed to me by value. Okay. So what is the problem? How to access x, which is a name, which is an attribute. This is a usage of this. Okay. So if you will use exactly the same name as a name of the attribute, then you can prefix it with this, and it allows us to deal with the problem of the hidden name. And the second example above, it calls the other constructor. Very often constructors are doing more or less the same, but are overloaded. So if you don't want to copy the code and you want to call the other constructor, and this is the way. Okay, so in C++ it was different. We have a list of initialization here, and here is the solution. What is important? If you want to call the other constructor, it has to be the first line of the body of constructor. Okay, and you can only do it inside the other constructor. You can also notice that constructors don't have a returning type because they are used on the object of a given class. Okay, so by default, rectangle is working on rectangles. That's why you don't have to copy the returning type. But this is the custom which you will meet in all object-oriented languages. Some specific ideas for Java, and maybe this is something which you are not aware of. This is the idea of nested classes. You could define a class within the other class. Okay? It is sometimes useful. It allows us to logically group the classes. Okay, so very local classes that are needed for some technical purposes, and you don't want to expose these nested classes to the outside world. Okay, so it is a next step in encapsulation, because you are encapsulating classes within classes. And very often, but not always, it can lead to more readable and maintainable code. Okay? And these two ABUs are very important. Readability, maintainability, this is something which is the core of programmers' life. Okay? So the way how you can access it, it's outer class.inner class. So it behaves slightly like package name, like namespaces. Okay, and then you can call the inner class. But notice how it is done here. Outer object dot new inner class, because the inner class object is within outside outer object. So it has to be created inside. Okay, so what we can notice here that we have outer class shadow test, inner class first level. Okay, and we have X here and X here, by the way, but both exist in objects. So inner class has an access to the outer class. Whatever you like, or maybe there is a Java development kit, okay? And it was explained on the first lab, by the way. So you're not accessing classes, this is your problem. So shadow class, shadow test is outside, okay? And notice, if I put x here, it is that x. If I will start this dot x, this is that x. And shadow test this x, this is that x, okay? So notice how encapsulation really works, and then you can use it. So what is important to notice here, that the inner class has an access to attributes of the outer class. That's why it has to be created inside an object of the outer class. So modifiers, we have public, protected, something which is called package, but no modifier, and private, okay? So, and the modifiers are before class, before package, in subclass, and other word, okay? So, but I think it is obvious, it's more or less similar like in C++. So if something is private, only the class methods could access it, nobody else. If something is public, everybody could access. Okay, if something is protected, no, not the world could access, etc. Okay, the next simple thing that exists on the Earth is a static idea. So we could make attributes or method static, and you already noticed the static method main, okay, because main has to be static. By default, all methods and all attributes are non-static. Okay, so attributes exist inside an object, and methods could have that are not static have an access to it. But sometimes, and this is a rare case, but existing case, happening case, that you need to deal with things that are not connected with objects, but are connected with classes. Okay? So let's look at this example. We have a class representing bicycle, but for some reason, I want to know how many bicycles are used or were created in my code. Okay, so the number of bicycle is an aspect of bicycle, but not a single bicycle, of object of bicycle, but just of a class of all bicycles. That's why, on one hand, I am encapsulating it because global values are forbidden in Java, and they should be forbidden in all languages. And I'm making it static because number of bicycles is connected with class, not with an object. Okay, so this is a variable which is common for all objects. It exists in a class in the sense that it has the same value for all objects. So this is not an aspect of the object in the sense that each object could have a different value. It is a common value for all objects. Okay, and we have static methods, and static methods are developed to deal with static objects. Okay, so if your method is prefixed with static, it means that it is not connected with any object, it is connected with all objects. So as a side effect, a static method has no access to non-static attributes. So it is forbidden to call cadence here because cadence is non-static attribute. So, and get number of bicycles is a static method. Okay, so only non-static variables of your class, only static variables of your class could be accessed in static methods. Okay, this is something rare in statics, but sometimes used. As a side effect, you can do strange things. You can access static elements without having an object. Static elements are not connected with objects, are connected with classes. Okay, so so you can use it like here, name of the class, not name of the, not reference to the object, but name of the class dot static method dot static attribute. Where we use statics, okay? I have told about most of things. The most typical, there are two cases, or the most typical two cases. Okay, the one case is if you have to store the data connected with classes, like that number of something. Okay, and the second case is for constants. For example, static final double p, or like p is a constant. Okay, so it's static because it exists for everything, and you don't have to create an object to access it. It is final. And final means it is not allowed to be changed in the future. Okay, and it is a custom in Java that constants are with capital letters. All letters are capital, not only the first one, but all letters are capital. Okay, we have a enum type, which is a really set of public static. Okay, so we can define a day as a Sunday, Monday, Tuesday, Wednesday. Okay, and then access to it. It was simple. Maybe some of you are already tired. Sorry. Now we will go to something slightly more sophisticated. Of course, we'll finish with the most sophisticated stuff for today, of course, because we'll fastly move to things which are not so simple as we started today or as we started last week. So inheritance. The idea of inheritance that you should be familiar with, because it is the second basic idea of object-oriented programming, is idea that we could define a new class that extends the parent class. Okay, so class mountain bike extends bicycle. Okay, so we have the idea of superclass and subclass. Okay, so the parent class and the subclass. So why we are defining subclasses? Subclasses are, in most cases, some specifications. So we have bicycles, but road bicycle and mountain bicycle differ somehow. Okay, so road bicycle is a bicycle with some extra features. Okay, so it has features of bicycles, but some elements, so there are some extra elements. Okay, or there are some change elements, some extra attributes, extra methods. Okay, so really in programming, since the object-oriented program is a set of classes, so programming in object-oriented languages is defining objects and really defining the tree of objects. Okay, so the process of defining classes is very often connected not only with defining separate classes, but the programmers or the designer modeler has to define common features of low level or the ending objects and define some superclasses. So if two things have something in common, very often you are defining a superclass. It simplifies the code and speeds up the code because you don't have to duplicate the code. Okay. What is important that subclasses inherits all the members, fields, methods, and nested classes. All the members, but not all are visible. It is not an error. It is a true statement. The example, if the bicycle will have some attribute which is private, you will be not capable of changing its value directly from road bike. Indirectly, yes. How indirectly? By a method that is not public, but it was defined inside bicycle. Okay, so everything exists, but not everything is possible. Constructors are not inherited by subclasses, but indirectly could be invoked. What is a nice feature of Java, and you probably are familiar with that feature from C# language, but the C# is 5 years younger, and really the idea was copied from Java. The idea of the object type. All classes inherits from the parent, even if you are not static and formal. Okay, if you will not use extents in your class, and probably in task for the lab, for today lab, you have not stated in most cases, but yes, there exists a superclass called object, and object is at the beginning of the inheritance path. Okay, so everybody, all objects in any Java code has a common parent called object. So even if you will define a class without any method, it will have a large number of methods inherited from object type. So it is worth to spend some time to see what is object. Okay, so let's look at the code. We have a bicycle, okay, constructor, public, protected, and private. Okay, I have told you already that everything should be private or sometimes protected. Protected behave similarly to private somehow. But here, I'm not following the rule just for the teaching purposes to show you how it behaves. What is the difference between word public, protected, and private? Now, from the inside of bicycle, there is no difference. Okay, you can access all three attributes. Next, we have the next class, mountain bike, that extends bicycle. Okay, and it has, again, wrongly written, but for the teaching purposes, seat height, okay, which is public. Okay, and notice that I'm here using the magic word super. Okay, so super behaves similarly like this, but it is used to call your parent constructor. Okay, so super calls your parent constructor, your superclass constructor. Since we have only one superclass in Java, it is obvious that super calls that constructor. Okay, so we can notice that I'm setting speed. Okay, so I'm accessing the speed from the subclass, even if it is private, and directly through public constructor. So, okay, speed is private, so mountain bike is not allowed to directly set the speed, but it could access it indirectly by calling some public or protected method. Okay, I have a set height, it changes it. Okay, and notice here, and I have a method test. Okay, this is just for teaching purpose. So I could access cadence because it is public, so it's obvious. I could access gear. Gear is protected. What does it mean, protected? Protected is private for the outside world, but public for all classes below. Okay, all classes in a chain of inheritance. Okay, so it is accessible for subclasses. Okay, so that's why gear could be changed inside a method coming from the subclass. But speed, that's why it's in red, and will rise an compilation error because speed is private. So I am not able to change the speed here. The only way is through some public methods or protected methods somewhere here. So inheritance, this is summary of stuff I have stated before. Since always some students are missing, I'm doing such things to allow them, but also you to memorize or just to come back to slides and do it by yourself without my speech. But what is important, okay, maybe I have not stated, is the last statement. It is a very important statement that shows also why we are using it. Since subclass has all methods and attributes of the superclass, so it behaves like a superclass, okay? So I could place an object of subclass type in any place where a subclass type is expected. Let's come back to some real example. Okay, let's assume that the university has a method, because university as everything is an object, and a method requires university teacher as an argument. Okay, and I am Thomas Walkowiak University teacher, so I inherit all the attributes of university teacher. So I'm not the same type. I'm a subclass of university teacher. So me as an object could be placed where the subclass type is expected. Okay, so in a classical programming, the types has to agree exactly. But in object-oriented programming, we can always put an object of the subclass type in the place of the superclass expected type. Okay, so this is a very important aspect because it allows future changes in the code. Okay, you can develop a code and expect some type and develop a new class based on that expected type, and object of this new type will fit to that attribute that was defined 10 years ago. Okay? Even you have a new type, but if it is the same type in the sense of inheriting its parent, it is working. So some ideas connected with types and checking the type, it means casting and instance of. Okay? A mountain bike is a bicycle. By the way, it's also an object because everything is an object. So just look in the code. I'm defining a bicycle as a type of an object, of an reference, but I could place there mountain bike, and it's okay because all mountain bikes are bikes. Even more, I could have a type of object and I could place there a mountain bike. It fits because a mountain bike is an object, because everything is an object. Doing it in the opposite way is illegal. It is illegal to put an object into a mountain bike, or only it is legal if an object is really a mountain bike. So you have to state it directly. So if you are sure as a programmer, as a human being, that always that object is mountain bike because you analyze your code, then you could force the casting. But if an object will be not a mountain bike, an exception during runtime will be thrown. Okay, and we will come back to exceptions soon. So if you want to be sure really there is a possibility of doing it by code, we have an operator called instance of that checks if an object is of a given type. But it's not exactly of the type. So what does it mean? Object instance of mountain bike. That object is mountain bike or anything else that inherits from mountain bike. Okay, so this is more broad idea than just exactly the same type. Okay, so it's the same type and all inherited types. So object, a nice idea is a class that sits on the top of class hierarchy tree. Object class provides a callback method, finalize. Provides a method toString, get class, and etc. As a homework, just find a documentation of object type in Java, just anywhere in the internet, and notice how many methods are there. Since everything inherits from objects, you will notice soon, well, just give me a second. And you will notice soon that there are a lot of methods inside. Since everything inherits from objects, that everything, all objects have that methods. I will like to compare you, to pay your attention on 3 methods, but this is not all, okay? But I think that these 3 are very often used. The first problem is finalize. What is finalize? Finalize is connected with memory management. On contrary to C++, we don't have a delete operator. Okay? We are just creating objects, but we are never ever in Java deleting objects directly. It is done automatically by memory management system. Okay, so garbage collector, so-called. Unused memory is a kind of the garbage. So when a garbage collector wants to or tries to clean the memory, he or she, whatever his gender or her gender is calling the finalize. So finalize is not a destructor in the sense of C++, but it's called in the same moment. Okay. So what is the purpose of using finalize? It is similar to the purpose of using destructors in C++, but not exactly the same, since you don't have to clean the memory. So the most typical situation for destructors in C++ is to clean pointers, so to delete pointers to some memories, objects that were created, for example, in a construct. So such need is not existing in Java, since like similarly to C#, since that language, like also Python, it has a dynamic memory management system. Okay, but there are cases that you are doing some stuff in a constructor, and at the end of life of an object, you should remove it. Examples later on in 2 or 3 weeks, we'll talk about network programming in Java. So we'll talk about how we can open a TCP/IP connection, for example. So you will create a class that will connect to some other server. So it will open a TCP/IP connection, for example, in a constructor. So of course, you should close that connection sometime. When to close? When the object will be not needed. Okay. So how to know when your object is removed from memory? Is finalized. Okay. So finalized is quite rarely used nowadays because compared with C++ and destructors, but sometimes really you have to use it in cases, but not the cases with memory, because we have an automatic removal of elements. Okay. Next element, much more often used, it's a method to string. All objects has a method to string. By default, the method is doing nothing, just returning an empty string. But whenever ever you will use a plus operator, and on the left-hand side, you will have a string type. Okay. Then whatever is on the right-hand side of the plus operator will be automatically converted to string. Okay. I have stated that sentence a week ago. How it's done? In case of built-in types, it is done as it is done. Okay. But in case of object types, and almost most of the types are object in our codes, especially in Java, in that case, the to string method is called. Okay, so if you want to convert your object to string for some purposes. I don't know what other purposes, but for any purposes, then you have to just overload that method. So define a new method to string inside your object. And then you can cast anytime your object into string automatically. So automatically to string will be called. Okay. The next method that maybe you don't have to overload, but very often it is useful to use it, is a get class. Okay, get class is available on all objects since it comes from object type, and it allows you to check the name of your object, because get class returns a special class object. Okay, this is object of the class type. This is a built-in type in Java, and it has a funny set of a lot of methods. But one of the methods there is get simple name. It returns the name of the class. So if you are unsure what is the type of the object passed to you, you can always check it using it. And finally, for that slide, a method called equals. It is, let's say, very useful to overload that method for specific cases. Cases connected with identity operator, equal, okay? Because what does it mean equal, okay? How check if their two objects are equal, okay? It is a specific situation and really depends on objects, okay, you are dealing with. And you have an example here. What does it mean that two books are equal? If they are, okay, let's define equality if they are exactly the same books with the same content. And you probably know that all the books, or most of the books, all the books that are published officially, let's say, has something which is called ISBN, a unique number. I have a book at my face, I see that number, okay? So if I will notice a book with the same ISBN number, it is exactly the same book, okay, in some sense. So if you need an equality, such operator to be used for some purposes, for your classes, you have to define it. Because by default, equality of objects is just equality of pointers. So if I exactly the same instances, okay, but if you want to have equality, not in the sense of the same instances, but into the sense of some semantic, you have to define the sense. And why you have to define? Because it is undefined in general sense. Okay, what does it mean that two cars are the same? I don't know. It depends. What does it mean car in the sense of your code? So you have to do it inside your code, and then a lot of methods connected with, for example, sorting and other stuff could be used here to solve some problems. Okay, we still have some time, and it is nice because I want to just start some other elements. So give me a second, okay? And it will make your life easier in sense of lab, because lab are very fastly going in future elements. So let's start to describe you the most sophisticated element of the three ideas I have presented on the first slide. So behind us, we have encapsulation, we have inheritance, and the last one is a polymorphism. Polymorphism is a very nice and useful idea, but it is not so simple as these two previous ones. Okay, and I will try to explain it on some examples. Okay, so polymorphism is the ability to use any class instead of its parent class on one hand. Okay, so it is connected with, of course, with inheritance. And anytime, if I have a class dog that implements animal, in a place of animal, I could put dogs. It could be seen as a kind of upcasting, or upcasting that subclass could mimic the upper class. But what else? What is the next very important feature of polymorphism is that you could override methods from parent class. You can override methods from parent class. So you can define a, like for example, to string I was talking about on the previous slide. So you can change the behavior, because methods defines behavior of objects in future. Okay, why it is so important? Just look on the right hand side of that slide. In 98 or 99, when Swing as a method of developing graphical user interface for Java was introduced. Okay, now we have JavaFX, so this is, but at the first version we have AWT, so this is something in the middle, but it was 23 years ago, okay, so many times ago. I have, or somebody develop a code, or just the son, because it was son during the time, develop a code that is capable of understanding classes and capable of plotting the result of these classes on the screen. Okay, so how it is done? The code, the virtual machine runtime expects an object of class JPanel. Okay, so there is a method that expects JPanel, and the code, when you will look inside, the code written in 97 by Sun, really calls a method called paint in JPanel. And now, after 23 years, I'm creating my own graphical user interface. So how it is done in object-oriented program? I'm creating a new class that inherits JPanel, so that's why it is called my JPanel. And what I'm doing, I'm adding some my own functions, whatever, and also I'm developing a new paint method. That new paint method paints, for example, a circle, because this is my idea, okay? And I'm compiling that method. 23 years later, this is important aspect. And what is nice? That my panel fits JPanel because it is a subclass of the JPanel. It has the same method or even more, because we have some extra method coś tam. One nice feature. But what extra feature connected with polymorphism, which is a virtual methods in C++, is that I have redefined paint after 23 years, and the code written by some 23 years before my code is capable of calling my paint written 23 years later. This is the extensibility. So I could take a code, a class from previous years, and change it slightly, not copying the code, just using, extending and overloading one of the previous method, and the old code is capable to call this new code. This is magic. No, this is not magic. It is possible to be done. But this is the biggest strength of object-oriented programming. extensibility. Okay, so we can do things, we can prepare some templates, let's say, but the word will be used in different senses next time. And then you could just fill with your own functionality, and others' code is capable of using it. Okay, so this is just polymorphism, the capability of upcasting and overriding methods from parent classes. We see two ideas of polymorphism, so-called static polymorphism, static binding, and dynamic runtime binding, just polymorphism, truly polymorphism. Because what does it mean by, sorry, give me a second. So when you have your code and you put the name of the method without polymorphism, which is not true word, because in Java, by default, all methods are polymorphism capable, are virtual in the sense of C++. So all non-virtual methods, which are quite rare in Java, we could define exactly what will be the code, because the name of the method, the type, so you know where to find code. But when we have a polymorphism or runtime binding, it is more tricky. You are calling the method, but really you don't know. I mean, the compiler, the runtime machine has really no idea which method will be called, because it could be a method from that class, but from any subclasses, because it depends on the type of the object, of a real type of the object is placed here. So during operation, Java interpreter checks the class of the object, the type of the object, and calls or points to a method that is defined by the object itself, not by the code directly. Okay, so that's why it is possible to call something that will be provided in the future. Slight magic. A very simple feature. Technically speaking, it is realized by pointers. Of course, in Java, pointers are hidden, so you don't have a direct access to it. But in ancient time of C and before object-oriented programming, we were doing that magic when I was in your age. Okay, we're doing it by using a lot of pointers to functions. Okay, but then the code was prone to errors, was unreadable, and now we have the same capabilities, but in a very nice, readable way. And this is the strength of object-oriented programming. This is something that is the core of object-oriented programming. So encapsulation, of course, inheritance, because polymorphism is strongly connected with inheritance. But polymorphism is that is something that is one of the main reasons, I think, okay, why all languages nowadays are object-oriented. Okay, so the type of the reference object, not the type of the variable, determines which method is called. Okay, so you could not do it, decide which real method will be called just looking in the code. It depends on the runtime. Okay, so let's look at the example that shows the magic. Okay, so we have shape, and we have three subclasses: circle, square, and triangle. And all these three subclasses overload the draw and erase from the parent. Okay, so I am creating a shape, and I'm putting the circle, but s.draw. Okay, if I will hide that line and I will put s called draw, it is hard to decide what will be called. It depends what we have inside shape. Okay, just now we know, because of the sequence of comments, that really draw is not shape, even as shape, but since we put the circle, we have here, sorry, not in that direction. So we have here circle draw. Okay, that's the magic. That line is not enough to understand the code. We have to know the type of the provided object, a really provided object. Okay, so circle draw will be called. This is polymorphism. So the really called method depends of the type of an object, not of real object, not of the type of variable we have here. Okay, so upcasting. Okay, it is hard, I know, but I hope that soon you will understand in practice. So as a joke, okay, at the end of the lectures, an example. So we have shape, withdraw, circle that extends shape, square that extends shape, triangle that extends shape, and shapes. Okay, and shapes returns circle, square, or triangle by random number generator. Okay, and you have here an example of random number generator in Java. And just look, what is the strength of object-oriented languages and polymorphism? The first strength is shown here. We have table of shapes of shape type, and you can put there shapes, squares, triangles, and it works, which is a magic compared with old languages, because we could put different types to the same table, the same array. Okay, and we are doing it randomly, so we have shapes of different type, and then we are calling shape draw. Oh, really? We are calling square draw and triangle draw. So we are just notice what is the next step of abstraction I want to point your attention. Just notice that strictly speaking, shape draw and shape arrays is never called. It behaves like a abstract element just to define a parent in inheritance tree. Why it is needed? Because in our case, it will be not possible to put squares and triangles into the same array, because without their parent, it will be not working. Okay, so the results will be in the random way. Okay, so it's extensibility, the next aspect that is realized by polymorphism. Why? Just look at the example. We have class instrument. What is instrument? Something that plays something. Okay, play a note. So I am defining a wind instrument. Okay, I'm playing, and I have a music that is a method that takes an instrument and plays a note. Okay, maybe I'm not happy with wind instrument. I want to extend my band with some extra instruments. So after 5 years, I'm adding a new instrument, whatever I like, but the code will be still okay. If the new instrument will extend instrument, music is okay, it's working. Okay, so a method during polymorphism define a superclass is redefined, specialized, some extra features added to it in a subclass by a method with the same signature. So overloading polymorphism works, but notice that method has the same name and the same argument, so has to have the same signature. This is the very important aspect of polymorphism. So after that 5 years, I will add to my band string instrument, but still the old code is working. Still the music method tune is working. Why is working? because that new object of a new type implements or extends, really, in that case, in that sense, instrument, which was defined before. So really, when you are developing a code, you are defining classes, of course, but very often it is a very useful idea to find similar features between different classes and define a subtype, because it allows us to do such things like here. Okay, so to group elements, treat them similarly, even if they are different. Okay, so strictly speaking, object-oriented programming is not only defining classes, I mean names, attributes, which are private, by the way, okay, methods, public interface, but also is a construction of the inheritance tree. And very often, we are adding to that structure things that are never called. Just notice that I never called instrument directly. I'm just using it as a type, but just look in that code and look in that previous code on the previous slide. Never ever I have used shape here directly. There was no new shape. Or maybe, sorry, it is, yes, there's no new, yeah, I'm declaring here an array of shapes, but never I created a shape directly. And this is the next idea that I will start the next lecture next week. I mean, abstract classes, abstract methods that will lead us to interfaces. So the pure virtual methods in the sense of C++. So thank you very much for your attention. I will put the slides till tomorrow on ePortal, and we will meet, of course, today and on Friday on Labs. And I hope we will meet together on the next lecture, that we will go further with object-oriented aspects. So I mean things like abstract methods, interfaces, and exceptions, and more or less we will finish with. And then we go into mentioned by me. Sorry, I have templates. And we'll finish basic ideas of Java. So it allows us to switch into more sophisticated elements, I mean threads, which will be in 2 weeks. So thank you very much again, and bye-bye.
Sorry, sir. Can I have a question later?
Yes. Yes, why not?
Okay, so I'll just wait till everybody leaves.
Okay.
The question
Notice that the break is very short. So
okay.
What's your name?
Sorry?
What's Perliński Jakub? Okay, so